Okay, so this is the video for parallel lines and perpendicular lines. We've talked about this a little bit in class, so let's talk about parallel lines first. What do we know about parallel lines? How could we define them? There's a picture here that helps us to look at it. We could say, for a definition of parallel lines, that it's two lines that never intersect, right? That will never cross. That never intersect. Okay, so what do we know about the slope then? This is what we explored in class. What do we know about the slope of two parallel lines? If they're never going to intersect, their slope has to be the same, right? So they're going to have the same slope. That's really important to remember. All right, so there's a song that can help us to remember this, and it's called the Parallel Line Song. And it's to the tune of the song Skip to My Lou, if some of you guys remember that. Okay, so I'll sing it here so we can think about it a little bit. It's parallel lines have the same slope, parallel lines have the same slope, parallel lines have the same slope, and never will they meet. Okay? That's a great little jingle that we can use to remember about parallel lines having the same slope. And we'll keep using it as we go through this video to remind ourselves. Okay, so if we know that parallel lines have the same slope, let's look at these examples. It says to find the slope of a line that is parallel to the following lines. Okay, well, if we look at the first one, we need to know its slope to be able to find a line that is parallel. And remember, parallel lines have the same slope, okay? So in the equation, y equals 4x plus 2, our slope is our m, right? Y equals mx plus b. This m was our slope. Okay, so in the first equation, our slope is 4, so if it's a parallel line, it has the same slope. So the slope of my parallel line would also be 4. Okay? Let's look at the next one. It says y equals negative 2/3 x minus 5. What do you think would be the slope of a line that is parallel to this one? Just so we remember, this is the symbol for parallel lines. I would say our parallel line has a slope of negative 2/3, okay? Because parallel lines have the same slope. Parallel lines have the same slope, right? So how can we determine if two lines are parallel? Well, we have an equation up here written in standard form, and we have one that's written in slope-intercept form. Which one tells us the slope? Our slope-intercept form does, right? It's our m. So if we look at the equation that's y equals mx plus b, what do you see its slope as? Good, I see it right here. We have a slope of 3/4. So we would know if these lines are parallel if this line over here also has a slope of 3/4. So let's rearrange it and put it in slope-intercept form so we can check. How would we do that? We have negative 6x plus 8y equals negative 24. Well, we need this to look like y equals mx plus b. So I'm going to try and get y by itself. That means I need to move my 6x. So to move it, I do the opposite. If it's negative, I need to add it. Okay? And my new equation is 8y, because my negative 6x and positive 6x cancel, equals, and I'm going to write the 6x first here because it helps me see slope-intercept form better. So I'm going to say positive 6x minus 24. Okay, does this tell us the slope? Well, not quite, because we still have a coefficient in front of y that isn't 1. Okay, we need it just to be y equals, not 8y equals. So let's divide both sides by the coefficient of y. Okay, what we're left with is y equals, well, what's 6 divided by 8? 3/4 x. And then what's negative 24 divided by 8? Good, negative 3. So 3/4 x minus 3. Did we get a slope of 3/4? We sure did. So these lines are parallel because parallel lines have the same slope. So let's look at writing the equation of a line that contains a point. So we're given the point 2, comma, negative 6. And remember, this can be thought of as an x, comma, y. And it's parallel to the line y equals 3x plus 9. Well, what does that mean to us? That means that we have a slope of 3, and if it's a parallel line, it needs to have the same slope, because parallel lines have the same slope. So I could say this has an m of 3. Okay, so if I know my slope, I can start writing my equation of a line. I could say y equals 3x plus, do I know my y-intercept yet? Is this point my y-intercept? No, so I'm just going to have to say b. Once I get this far, I can use my point and plug it in where I need to, okay? I have up here an x of 2 and a y of negative 6, so I'm going to plug those in. I could say negative 6 equals 3 times my x of 2 plus b. Okay, so let's simplify. We'll solve for b. Well, negative 6 is going to stay the same. Nothing's happening over there. Equals, what's 3 times 2? Good, positive 6 plus b. How do I solve for b? What do I need to do? So it just says b equals. Okay, I need to subtract 6 from both sides. I'm left with a b equals, well, what's negative 6 minus 6? Good, negative 12. Okay, now that I know this, I can plug it back in and I will have my equation of a line. So I can say y equals 3x plus negative 12, or some of you might prefer seeing y equals 3x minus 12. Okay, those are the same thing. That's both okay. All right, so let's talk then about perpendicular lines. Do we have a definition of perpendicular lines? We can look at our picture here. Remember, there are two lines that intersect. And what do they make? What is that little green square down there? Tell me. Good, they intersect and they make right angles. Awesome. All right, so if they intersect and make right angles, what did we find out yesterday about their slopes? All right, we know that their slopes are opposite. Okay, they're opposite. And we need to find something called the negative reciprocal. Okay, this is a big word that means when you have something, we're just going to talk abstractly. Let's say we have something like A over B. Okay, the reciprocal, you guys remember this from fractions, means that we flip them. Okay, so that would make it now be B over A. Okay, and since it's negative, you do the opposite. If this was positive before, now I make it negative. Okay, we'll talk about that a little more over here. We have a song to help us remember this one as well. Okay, this is to the tune of the peanut butter jelly song. Remember? Peanut, peanut butter, and jelly. That song. Okay, so I'm going to sing this one and we'll use it as we work through problems about perpendicular lines. Alright, perpen. Perpendicular, right angle. Perpen, perpendicular, right angle. First you take the slope and then you flip it. flip it. Then you take the slope and do the opposite, the opposite. Perpendicular, right angle. Okay, so these steps right here are how you find a negative reciprocal. That's what we were just talking about. You need to take your slope and flip it. Then you take your slope and do the opposite. Alright, so let's look at these lines. It wants us to find the slope of a line that's perpendicular to the following lines. So we have our first line here, which is y equals 4x plus 2. Well, to be perpendicular, we need to find the negative reciprocal of our slope. So what's our slope here? Okay, we have 4 as our slope. How can we flip that? It's just the whole number. Okay, we need to think of 4 in fraction form as 4 over 1. So let's use our songs. First, you take the slope and then you flip it. Flip it. So now instead of 4 over 1, it's 1 over 4, 1/4. Then you take the slope and do the opposite, the opposite. Okay, if this is positive, it changes to negative. All right, let's practice with our second one. We use the same process. This one, we have an m, or slope of, good, -2/3. Okay? So first we take the slope and then we flip it. Flip it. So it's now going to be 3 over -2. Then you take the slope and do the opposite. The opposite. Okay? Our negative becomes positive. So we could just say our perpendicular line has a slope of 3/2. We flipped it and did the opposite. Okay, so let's determine if these two lines are perpendicular. Well, to start, we need to find the slope of one of these lines. Okay, the first one is in y equals mx plus b, so we can see our slope right here. It's our m, and it's -2. Okay? Let's think for a second. We need the other line to be perpendicular, so what would its slope have to be? Okay, for our perpendicular line, the slope, we would need to take the slope and we flip it, okay, so -2 could be thought of as -2 over 1. We flip it to 1/2, then we take the slope and do the opposite, Okay, so we will know these lines are perpendicular if our second line has a slope of -1/2. All right, let's work through here and see if we can put our second line into slope-intercept form and see what our slope is. Okay, so for slope-intercept form, we need y equals mx plus b. How do we get y alone? Well, we'll have to move our x, so if it's positive x here, or we can say positive 1x, we need to do the opposite. So we'll add 1x to both sides. Okay, sometimes I draw a line through the equal sign so I can see both sides of the equation. Okay, whatever you do to one side, you have to do to the other. So here I added 1x, and we know that this is going to cancel. Because -x plus x is just 0, and we're left with 2y equals, well, can I combine a variable with a number? No, I can't. It would have to have an x with it for me to combine them. So I'm just going to write 1x plus 8. Okay? Now, what do we need to do? We have 2y equals, and I just want to know y equals. All right, we'll need to divide both sides by the coefficient of y. So divide them by 2. What are we left with? Well, 2 and 2 cancel. And we're left with y equals, what is 1/2? 1 divided by 2, right? X plus 8 divided by 2. 8 over 2 is 4. Okay, so in this second line, we got an m, or a slope of 1/2. Is that the same as what we said we needed over here? We said we needed -1/2. So these lines are not perpendicular. Okay? So very last thing, let's look at how we can write an equation of a line when it gives us a point and tells us a line that it's perpendicular to. Okay? Well, with our point, we have an x, comma, y. Okay, let's keep that in mind because we can plug that into our equation again. And it says it's perpendicular to the line y equals 1/2 x plus 1. Well, here our m, or our slope, is 1/2. So for a perpendicular line, we need to take the slope and we flip it. Flip it. So 1/2 is 2/1. Then you take the slope and do the opposite. The opposite. The opposite of positive is negative. So our new line needs to have a slope of -2/1, or we could just say -2. Alright, so let's plug in what we know. Our equation is going to be y equals -2x plus our y-intercept. Did they tell us? Nope. So we'll just have to say b. Now, can we solve for our y-intercept so we can complete the equation? Well, they gave us an x and a y, remember? So let's plug in our x and our y. We have a y of 8, so we could say 8 equals -2, that was our slope, x plus b. Well, did we know an x? Yeah, we did. Okay, our x was 1. So it's 2 times 1. Let's simplify. We can say 8 equals -2, because -2 times 1 is just -2, plus b. Alright, how do we find just b? We need to move our -2, so we'll do the opposite. We'll add it to both sides. Okay, and we're left with 8 plus 2, which is 10, equals, well, -2 plus 2 is 0, so we're just left with b. Can we now plug this back in to our equation, remember? Alright, so our new equation of a line, we can say y equals -2x plus 10. Okay, and this line over here would be perpendicular to the line y equals 1/2 x plus 1, and it would go through the point 1, 8. Okay, that's your video for parallel and perpendicular lines.